All right, welcome back to day 2 of section 6.5, Systems of Inequalities. Day 1's notes, we dealt just with singular inequalities, so we had one line or one quadratic or one circle. Today we're actually going to get into systems where we have 2 or more equations. And so this first one here, we've got 2 linear inequalities, and that's pretty typical for what we'll see. Primarily linear, though we'll see a few other nonlinear examples. Both of these are in slope-intercept form. So this first one, that's the solid blue line. Again, solid line because you have less than or equal to. The red one's dotted because we have greater than. When I do my test points, for the blue one, it's false. So for the blue line, I'm going to need to shade away from 0, 0. And for the red line, it's true. So we're going to shade towards 0, 0. When you are doing these inequalities, you want to pick the solution region that satisfies both. Kind of like when you're buying a car. If you have a budget of $3,000 for a car and you want one that's front-wheel drive, you're not going to go look for a car that's $5,800 and has rear-wheel drive. That makes no sense because it's not meeting your conditions. So it's the same idea here. We want to satisfy both of these. So the region that is shading away from the blue line or away from the test point with the blue line and towards the test point with the red line is this area right here. This is the solution region that will satisfy both of those inequalities. All right, our second example here, we have parallel lines. Now you may not see that at first because they're in standard form, but if I solve both of these for y, you can see that they have a slope of negative 2x. So the fact that they're parallel here, that's okay. That's not why this is no solution. The reason why this is no solution is because they don't have any common areas as part of this solution. So for this first line, if we do the test point 0 greater than 2, that's false. So we would shade out here. And for the red line, 0 less than 2/3, that's true. So we would shade over here. The issue is when you have a system of inequalities, it's the overlapping solution region, and there isn't any. There's no area on this graph that satisfies both of these conditions. And so for that reason, we have no solution because we can't satisfy both at the same time. All right, again, here's another example, 2 linear inequalities. And again, I've got to get them into slope-intercept form. You could leave it in standard form and find the intercepts. The problem here is you're going to get a fraction with this 5 and 12. So I just changed it to slope-intercept form. Same thing here. So I've got 2 different slopes. I know these lines are going to cross. First one's dotted, second one's solid. And when I check my test point for the blue line, it's false. And for the red line here, it is true. So for the blue line, I am going to shade away from the test point, and for the red line, I am going to shade towards the test point. And so the region that's going to be our solution is right here, and so we're going to go ahead and shade that in. All right, so now you can see that that area has been shaded in. It satisfies both. For the blue line, we've shaded away from the test point. For the red line, we've shaded towards, and so this is our solution area. Again, when you shade these in, you don't have to be perfect, but do your best there. We don't want your shading to be way outside the lines or look sloppy, but do the best you can there. It's not necessary to shade this whole thing in either. Some people will just kind of put a few lines, space them out and shade it in that way. That's perfect. All right, here we have a circle, and we can see our center point is at 2, -5, radius of 3. So the first thing I did, I graphed this circle. It's a solid circle because of greater than or equal to. When I put my test point in, you can see that we got a true solution. So when I plug 0 in for x and y, 29 is indeed greater than or equal to 9. So we're going to shade towards our test point. So you can see this graph, it's the entire area outside of the circle. If it was false, then it would have been inside the circle. Shading, again, if we shade away from 0, 0, that would have been inside the circle. Since we're shading towards, it's the area outside. So that's a little different with a circle than with a line. Okay, now again, we still have a system of inequalities. This time we have a linear equation and a nonlinear, in this case a quadratic. So this first one here is going to be a solid curve, solid because of the greater than equal to, and we have a parabola opening up starting from -3, and then our line is also solid, less than or equal to 1/2 x plus 4, so y-intercept of 4, slope of 1/2. When I do my test point for both equations, works for both, so in both cases we are shading towards 0, 0. So that's the region that is inside this parabola and underneath this line. So that's the region that is towards 0, 0 right there. The reason I can't shade any of this, yes, it's under the red line, yes, it's shading towards 0, 0, but that is shading away from 0, 0 in relation to the blue curve. So again, it's got to satisfy both. Okay, now you see 3 lines. And you may see this on the homework as well as on the quiz, and that's okay. Again, I advise you put them in the slope-intercept form first. That's going to be the simplest way to go about it. So I moved 3x over here, then divided by 2. Here I move the x over, divided by -4. So that's going to end up being a positive there. And then here just subtracted 2x. So now I've got 3 linear inequalities. They are all less than, so that's why they are all dotted lines. And I use 0, 0 again for my test point. And it was true for all 3. So I have to shade the region for all 3 that is going toward 0, 0, and that ends up being this trapezoid looking section right here. If I go in any of these other sections on the graph, it only satisfies 2 out of 3 or 1 out of 3. And again, we have to satisfy all 3 of these in order for it to be a solution. Okay, again, here we have 3 inequalities. This time we have 1 quadratic and 2 linears. That's fine. So y greater or equal to 0, that's solid. X greater or equal to -1, that's also solid. And then we have our quadratic here opening down because it's -x squared. I couldn't use 0, 0 this time because that's on this line. So as long as you pick a point that's not on one of the lines or curves, that's going to work. So I just picked 0, 1 in this case. And 0, 1 does work for all 3 of these. So again, for the blue line, purple line, and this curve, we are shading towards 0, or excuse me, towards 0, 1, not 0, 0. And so that's this little region right here that satisfies all 3 conditions. And again, regardless of how many inequalities you have, whether you have 1, whether you have 2, 4, the solution region has to satisfy all 3 of them. It has to make them all true. Okay, a little different here because we have a quadratic shape, but it's opening sideways, and here's why, because we have y squared. And so if I solve this for y, I really got to take the square root of x. Now remember, if you take the square root, you get a plus or minus. So the positive square root of x is right here. The negative square root of x is right here. So really, to have this full graph, you do need both halves. This is dotted because it's less than. And then we have a linear equation here, also a dotted line because it's greater than. So here I can use test point. And what I did is I used 0, 0, excuse me, used 1, 0. Let me go ahead and change that. Sorry about that. So if I use 1, 0, and now we go about this, I've got 0 less than the square root of 1. That is true. And then when I check this one here, I am going to have 0 greater than 1 minus 2. That is also true, as 0 is greater than -1. And so I use the test point 1, 0. My apologies there for that mistake. And because of that, you don't really need the plus minus here. You just take the square root of 1. So because of that, this is our region right here. So we are inside, or shading towards this point for the quadratic, the square root of x, and then shading back towards it for the line. All right, one last example for you today. and that is going to be our double circle here. And so we've got two circles in this example. Both of them happen to be centered at 0, 0. So you notice there's no number subtracted or added to x or y for either one of these. So I've got two circles centered at 0, 0. The smaller one, radius of 1. Larger one, radius of 3. Both solid. And here I can use 0, 0, so that's what I did. So for the little circle, if I put 0, 0, that's false. So I'm going to shade away from the red circle. And for the blue one, 0, 0 is true, so I'm going to shade towards. Now remember, it's got to satisfy both. So the region that's going to satisfy both of these, greater than this circle and less than this one, is this area right here. So we have this donut-looking shape because that is the solution region that satisfies both. So again, that's systems of linear inequality, or systems of inequalities, whether they're linear or not, where you'll see 2 on most of your examples, 3 on a couple of them. Again, if you got any questions, let me know, and we'll go from there on our help sessions this week. Appreciate it. Thanks.